Okay, this is lesson 9 for 8th grade, and today we're talking about prime numbers. Prime numbers are some of my favorite things to work with, and it's because they're pretty fascinating, especially when you get into a higher level class of math. They do some pretty crazy things. We're going to start on a basic level, obviously, but this is a good start. Okay, we call prime numbers. They are counting numbers greater than 1 that have exactly 2 different counting number factors. Okay, so the 2 factors that go into a prime number are the number itself and 1. Now right off the bat, let's take a look at this definition. It's important to note that they are numbers greater than 1. That does not include 1. 1 is not a prime number. So, just so that we know that. For example, 2, 3, 5, 7, 11, 13, they are prime. 2 is the only even prime number, so any other even number is not prime. Here's the reason why. The only thing that goes into, the reason that these are prime, let's take 3. The only factors that go into 3 are 1 and 3. Those are the only 2 numbers we can multiply together that are counting numbers anyway to get 3. So we're not including decimals or anything like that. So the only counting numbers that we can do to get 3 would be 1 times 3. That's why it's prime. There's nothing else that will divide it evenly. So let's take a look at 6 here. 6 is not a prime number because it has more than 2 factors. So it has 1 and 6. 1 and 6 are factors of 6, but also are 2 and 3. Now, the whole reason for this diagram is to show that if we use boxes, 6 boxes, we can arrange them into equal groups in 2 different ways. This one is a 1 by 6, so they're all on one level here in a row of 6. And this is true for any number, 1 times 6. But what else can we do with it? Well, we can put it into 3 groups of 2s. So if we try to do that for 7, let's say, we'd have a lot of trouble because the only situation we can have so that they're all on an equal level is 1 by 7. If we try to do that with this, we'd have 1 sticking out over here. 4, 7, that is. So 7 is a prime number. The only 2 numbers that will divide 7 are 1 and 7. That's why it's prime. Okay, so counting numbers with more than 2 factors are composite numbers. Okay? It's also good to point out where I said that 1 is not a prime number, but it's also not composite. So it's neither, greater than 1 are either prime. Okay, so counting numbers greater than 1 are either prime or composite. So they either have to be composite or prime, and 1 is neither prime nor composite. So 1 doesn't fit in either category. 1 is the loneliest number. Alright, so where are we going to use this? Well, prime factorization. This will come in handy later on. Let's take A here, 36. What we do with these is we make these tree diagrams, and the students will figure out 2 numbers that we can multiply together to get 36. So 36 can be multiplied by 6 times 6. So let's go 6 and 6. And what we're looking for here is prime numbers. And once we get this tree broken down into all primes, then I can show you what the prime factorization will be. Okay, 6 and 6 are not prime, so we need to break them down even further. We know that 6 is 2 times 3 and 2 times 3. So now we have all prime numbers. We've got 2's and we've got 3's. Alright, so if we multiplied all of these together, 2 times 3 times 2 times 3, we'd get 36. So basically what the prime factorization is its own little, every number has its own prime factorization, so it's like its own little code for itself. And here's how we would write it. We have two 2's, so that would be 2 to the second power, times, we have 2 3's, 3 to the second power. So that is the prime factorization of 36. 2 to the second is 4, times 3 to the second, which is 9. So 4 times 9, we would get 36. So that is the prime factorization for 36. Now let's take a look at 45. 45, we can break that down into 5 times 9. Alright, right off the bat we have a prime number here. 5 is a prime number, so I'm going to circle that. And then we've got 9, and 9 can be broken down into 3 times 3. Alright, so 2 more primes, and they happen to be the same number. So 2 3's, so that'd be 3 to the second times 5. Now the other thing to note here is that the standard protocol is to start with your lowest number and increase. So here I went 2 to 3, here I went 3 to 5. So start with the lowest number that you have and go upward. So that's the standard. Good. Alright, now those 36 and 45 were pretty easy numbers to work with because we know what goes into those. But we're going to end up working with some pretty big numbers. So they have divisibility tests that we can do to see which numbers will divide certain numbers, which will be very helpful. So here's a condition for us. If the number is even, so that would be ends in a 0, 2, 4, 6, or an 8, the number is divisible by 2. So an example, 3,420. That is not prime, it is composite because we know that 2 definitely goes into it, and so does 1 and itself. So that there's more than one divisor, or more than 2 divisors of 3,420. Okay? Now, if we want to check and see if the number is divisible by 3, we can add up all the digits, and if those digits are divisible by 3, so will the number itself. So they do 3,420 again, 3 plus 4 plus 2 plus 0, and you get 9. 9 is divisible by 3. That means this number is also divisible by 3. So that's a rule for 3. The number, okay, our condition, if we want to check 5, if the number ends in 0 or 5, it will be divisible by 5. So yes, this also follows that. And this is in the book, and there are also some other rules that they have here, okay? So, if a number is divisible by 2 and 5, a number divisible by 2 and 5 is also divisible by 10. Another thing to point out, if the number ends in 0, it will be divisible by 10. That's a more easy rule. So if you see a 0 at the end, that is divisible by 10. A number divisible by 2 and 3 is divisible by 6. So if 2 and 3 divide the number, 6 will also divide the number. And a number is divisible by 9 if the sum of the digits is divisible by 9. Kind of like the same rule for 3. So if we use 3,420 again, 3 plus 4 plus 2 plus 0, we get 9. 9 is divisible by 9, so 9 would work for that number. Alright? And a number is divisible by 4 if its last 2 digits are divisible by 4. So if we take 3,420 again, it ends in 20, so that's 20. And 20 can be divided by 4, so 4 would work for this number as well. Now, 2 other numbers that aren't up here, 7 and 8, those we just have to check on our calculator probably, especially for larger numbers. Those don't really have rules, so at least in the book here. So here's where this will help us. Alright, so determine whether the following numbers are prime or composite and state how you know. Alright, 1,237,526. Well, right off the bat, looks like we have an even number. So, you know that's divisible by 2. So this is composite. It can be divided by 1, the number itself, and 2, and some other number, at least. So there's at least one more than 1 in itself that will divide it. So that means it's composite. And we know this because it's an even number. B is not as obvious. It's not even, so 2 won't go into it. It does not end in a 0 or a 5, so 10 won't go into it, and 5 won't go into it. The last 2 digits, 11, are not divisible by 4, so 4 won't go into it. The one that we need to try is, let's add up the digits and see what we get. So 5 plus 2 plus 0 plus 6 plus 1 plus 1. So we get 7 plus 0 is still 7, plus 6, 13, plus 1, 14, plus 1, 15. So this equals 15. So this could either work for 3 or 9. 15 is not divisible by 9, so 9 doesn't go in here. But 15 can be divided by 3 evenly. So we know that 3 will go into this number as well. Therefore, this is composite 2. It would have been easy to say that this is prime right off the bat, but after we do a little bit of checking, we see that it is also composite, just like the other one. So just be careful, use those rules, and make sure that you are sure that it's composite or prime. Alright, that's the basic introduction to prime numbers, and we'll continue with lesson 10.